Okay, so today we're going to be starting kind of what I feel like is the meat of what we need to be able to do with factoring. This is like the important stuff. And it's going to look a little different what we're doing today than what we did during the first 2 minutes. So to start us off, I want you to go through as a little warm up and just multiply out these polynomials. So you can pause the video. I'm just going to kind of quickly multiply them out here. So distributing 2x, giving me 2x squared plus 16x, and then distributing 3x, giving me 3x plus 24. So 2x squared plus 19x plus 24 for my first binomial times binomial multiplication. And then on my next one, distributing x, giving me 3x squared minus 5x, distributing -2, giving me -6x plus 10, 3x squared minus 11x plus 10. For my second binomial times binomial. And last one here, 7n squared plus 42n, distributing the -4, minus 4n minus 24. That gives me 72n plus n squared plus 38n minus 24. Okay, and that's something we did a couple of units ago. So just multiplying binomial times a binomial. Now, we know that factoring is reversing that multiplication. And up until today, when we factored, really it was all about common factors. So we were looking and dividing out the common factor. Well, now, if we look at these trinomials that we've created, I don't see a common factor that I can factor out, right? So how do I work with a trinomial, okay, which is our focus today, factoring trinomials, 3 terms, okay? What does that look like? How do I go from here and I want to get it back to here? How do I get those 2 binomial factors that we started with? How do I work backwards? Okay, so I want to go through first, and let's look at how do we get the first term of our trinomial. Okay, so if I just go through the 3 examples we did, and let's look, when I look at my factors that I have up above, okay, 2x plus 3 and x plus 8, this first term is coming from multiplying 2x and x. 3x squared is coming from multiplying x and 3x. 7n squared is coming from multiplying 7n and n. So always the first term in my trinomial is coming from the first terms in each of my binomials. Or another way to say this is that the first term in each of my binomial factors are factors of this first term. 2x squared I can break into 2x and x. 3x squared I can break into 3x and x. 7n squared I can break into 7n and n. And now I want to look at our last term here. So positive 24, positive 10, and negative 24. And let's go back to our factors. 3 and 8, the last term in both my binomials, that would be factors of 24. Here I have positive 10, negative 2 and negative 5 would be factors of positive 10. And our last one, negative 24, negative 4 and 6 are factors of negative 24. So we can see that this happens every time I have a trinomial. The binomials that they came from, the first terms in those binomials are factors of my first term here. The last term in those binomials are factors of my last term here. So then the question remains, well, what about this? And this middle term is really like the key. It's what seals the deal and makes sure that we factor things correctly. And so this 19x is coming from combining these 2 terms when I multiplied, right? And this negative 11x comes from combining negative 5x and negative 6x, and then same idea here. Okay, so there's more we have to think about in terms of how we're creating that middle term, and we'll talk more about this as we look at an example together, okay? So we're going to look at one trinomial and talk about, well, how do I break it down? How do I factor it to get the two binomial factors? Okay, so we're going to look at 2x squared plus 9x minus 5. Now we observed up above that the first term, so when I factor, I'm taking the trinomial and it's going to factor into two binomials, a binomial times a binomial. And we observed that the first term here, okay, of each binomial will be factors of 2x squared, or the first term in my trinomial. So factors of 2x squared, if I were to break 2x is prime, so it has to be 2 times 1, or 2x times x. So to factor this trinomial, the first term that's going to be in my binomials have to be factors of my first term here. Factoring this first term, I get 2x and x. And then we noticed that the second term in each of the binomials, these second terms are factors of the last term here. So in our example, the second term of each binomial will be factors of -5. 5 again is prime, so the only factors of 5 are 5 and 1. Okay, so I know that I have 5 and 1 here, but wait a minute. It makes a difference if I place 5 here and 1 here, or if I place 1 here and 5 here. That's going to make a difference when things get multiplied out. So there's only one way to arrange the 2x squared, or it doesn't really matter. I threw 2x and x in, okay? Put those in your parentheses. There's only one pair of factors of 5, but where do we put the 5 and 1? So there's two options. One option is that I put 5 here and 1 here. And the other thing is we have -5, so we have to even think about the signs, but we're not quite there yet. The other option is I put 1 here and 5 there. And they're going to produce different trinomials depending on signs and where my factors are. Okay. The way to determine which possibility is correct, if I want this setup or this setup when I'm factoring, is to look at the middle term. And that's what I mean when I say that middle term is the key. Okay, looking at the middle term of our trinomial. And the middle term of this trinomial is positive 9x. Okay. So what I call it when we're looking to decide what's going to work is I call it doing an OI, Okay, and that comes from FOIL. So I'm looking at just the outer inner multiplication that happens right here, just this piece of the multiplication that happens. And so I look at the outer and the inner multiplication. If I multiply 2x times 1, I get 2x. 5 times x, I get 5x. Is there any way that we can make, given signs, positive, negatives, that I can make these two numbers produce 9x? The answer there is no, right? If they are both positive, it would give me 7x. If one was negative, it would be either 3x or -3x. That's not going to work, okay? Now let's look at the next possibility. So now all that we've done in our parentheses is we've flipped the 1 and the 5, where the 1 and the 5 are placed. If I look at the OI, outer terms give me 10x. Inner multiplication gives me 1x. We know we want our middle term to be 9x. Is there a way that we can make 1 and 10 produce 9? Okay, yes. Okay, and the way to do that is make this term negative, which is now how we place our signs. We want this to be -1x and this to be positive 10x. Okay, and that would add up to 9x in the middle. What these two numbers are, let me move back up for a moment, would be these two numbers here. Okay, thus 2x squared plus 9x minus 5, this trinomial factors, the factored form of that trinomial, into 2x minus 1 and x plus 5. Okay, these are the factors that I want, and that's what we're working on doing today. Taking a trinomial and breaking it into two binomial factors. And so just to show you why that's the combination we want, if I were to multiply this back out, I'd get 2x squared plus 10x minus x minus 5. 2x squared plus 9x minus 5, which is exactly what I have there. Okay, so if I multiply out my factors, I should be getting that trinomial that I started with. And just a reminder, the 2x and the x came from factors of 2x squared. The 1 and the 5 came from factors of my last term. The signs come from looking at my middle term here and deciding, or the placement of the numbers and the signs all come from that middle term. That's kind of our key here, looking at 9x and deciding, how do I make outer, inner be able to add? How do I make these terms be able to add up to 9x in the middle? So let's talk about these signs first, because there's a trick to know if you're going to have 2 positives, 2 negatives, or 1 negative and a positive when we're factoring. So if you flip this over, we have some trinomials, and they're already factored. So it's already been factored where it's placed the numbers in the correct spot. And we're just going to figure out the signs that we need to be. So we're going to look at the OI. Okay, we're going to look at that outer inner multiplication. And we're going to say, okay, what do I want it to add up to? Well, I want it to add up to 7x. So if multiplying here, this would give me negative 3x. And multiplying here would give me 10x. So do I want this to be a positive or a negative? Well, if I want it to be positive 7x, I want this to be positive 10, negative 3. That's going to add up to my middle term. Okay, that's how I decide my signs. Now looking at our next example. So notice it's still 2x and 15, but I have a different middle term, right? I have negative 13 in the middle. So if I look at outer, inner, 3x and 10x, if I want it to add up to negative 13, then I need both of these to be negative. Negative here, negative there. That would make our middle term negative 13x. Looking at the next one, outer, inner, 5x and 6x, and I want it to add up to negative 1x. So if I want negative 1x, that means I want negative 6 and positive 5. Negative 6, meaning this has to be a negative 3, making this multiplication negative 6, and that has to be a positive 5. Looking at the next one, if I look at the outer and inner here, I have 3x and 10x. And again, still notice, right? It's still 2x squared and 15. Those are my first and last terms. It's just changing what's in the middle. So now I want positive 13. So if I want this to add up to positive 13, then I want both my signs to be positive, plus there. Our last row here, so still 2x and 15, but I want it to add up to negative 7x this time, not positive 7x. So I have 3x and 10x. If I want it to add up to negative 7x, then I'm going to have negative 10, positive 3, negative here, positive there. On F, if I look at outer and inner, give me 5x and 6x, and this time I want it to add up to negative 11. So that means I need both of these to be negative. Negative, negative. Okay. So now we're going to learn a trick. So go back to the original problem and circle the constant, including its sign, meaning if it's positive or negative. So I'm going to just circle on each of these the constant term, that 15, but I'm going to include the sign. And so notice in this first column, they're all negative 15s. And in the second column, they're all positive 15s. What do we notice about the signs in the binomial? So in the binomial factors, what do we notice about our signs if our constant is positive? So take a moment and look at these. And what do you see? And what you should notice is that if I have a positive 15, I always have the same sign. So they're either both negative or they're both positive. They're both negative. Okay, that I have the same sign in both my binomials. They're either both positive or they're both negative. Now, what about when the constant is a negative number? So that's our first column, when I have negative 15. Look at our binomials. What do you notice about the signs? And you should notice that you have one of each, right? A negative, a positive and negative, a positive and negative. And that's because these last terms have to be factors of this, okay? So it has to be, to multiply to a negative, I have to have a positive negative here. Okay, but anytime I have a negative, what I call a C value, right? So I'll talk about that in a moment. We have opposite signs. Okay, one negative, one positive. So in my binomial, so our trinomials, standard form of a quadratic trinomial is this. I have ax squared plus bx plus c. So a, b, and c being some numbers. Okay, I'm talking about c here. So if my C value is positive, okay, if my C value is positive, then I will have the same sign. Okay, I'll have two negatives or two positives. If my C value is negative, then I will have opposite signs. I'll have one of each. And that helps me when I go to place and look at my factors. Okay, so that's all background material, all little pieces that come together to help us factor these trinomials. Now, we still want to ask ourselves, is there a GCF? That never goes away. Okay, if there's a GCF, we'll factor it out first. Okay, but now we're looking at polynomials and specifically trinomials that, for the most part, yes, if there's a GCF, we'll take it out, but now we're learning a new way to factor. A way to take these three terms and break them into two binomial factors. Very different skill than what we had been looking at previously. So no GCF, that runs across all of them. Going to factor this trinomial into two binomials. Now I know that the first term in each of my factors comes from factors of my first term here, which happens to be a prime number. So 3x squared, I can only break apart as 3x and x. So that's easy. Then what I do is I look at my C value. Because C is positive, I know my binomials will have the same sign. Well, which one is it going to be? Let's go back up. This column is where C is positive. Here, C is positive. Hey, look at that. Negative in the middle term became negative, negative. C is positive, positive in the middle term became positive, positive. C is positive, negative in the middle term becomes negative, negative. So there's a trick that you can use to help you factor these. Okay, when C is positive, not only will it be the same sign, but, and this is super important, it will match the middle term. Okay, so as I'm going through and doing this, write that here too, match the middle. I know that trick. I know that if I have a positive C value, I'm a little ahead of the game because I know my signs. It'll be whatever my middle term is. Okay, C is positive, middle term's positive. I know I have plus plus here. So now to figure out, I know that 5, okay, that these last terms here have to be factors of my last term. In 5, it's going to be 5 and 1. So I know that I'm either going to have a 5, 1 or a 1 and a 5. And to figure out how I place my factors of 5, that's where I look at the OI. So I look at outer and inner. And how could I get a combination that would add, and this is what I'm looking for, that would add up to 8x. Okay, how can I combine the 5 and the 1 in here so that I get 8x? And the correct factored form here would be to place a 5 here and a 1 here, because that's going to give me 5x on my inner terms, 3x on my outer terms, and that's going to add to 8x in the middle. That's how I know where to place the 5 and 1. I'm looking at what I call the OI, the outer and the inner. Okay, and really, and this is called guess and check method too. It's like a puzzle. You have to sit there and think about it for a minute. Where do all of these pieces fit together to work perfectly to create the trinomial that I want? So you can see on our next one, we again have 3x squared for our first term and positive 5 for my last term. What's different is the term in the middle. So to factor this, my first terms are factors of my first term here. So 3x squared, again, is going to be 3x and x. I always check my C value. It's positive with a positive middle term, which means both my signs will be positive. And now I want the outer and the inner terms. And you don't have to show this work. You can do that in your head. I'm just showing it so you know what I'm looking at. I know that 5, I'm going to place a 5 and a 1 in here, and I want it to OI to 16. So now if I put the 5 here and the 1 here, I get 1x and 15x. I'm adding up to 16x in the middle. Okay, this is the correct factored form of that trinomial. Okay, let's look at a couple more together, and then I'll give you a chance to try this. So next one, first term 2x squared, only one way to factor 2, it's 2 and 1. Again, positive C value, positive middle term. So that means plus plus are for my signs. Again, my last term is prime. It's going to give me 7 and 1. So now I need to decide where am I placing 7 and where am I placing 1 so that if I multiply outer and inner, it adds to 9x in the middle. And so I would need to place 7 here and 1 here. That gives me 7x and 2x adding up to 9x for my middle term. D is the same. So 2x squared in terms of the numbers I'm looking at is 2x and x, positive C value, positive middle term. 7 has to be 7 and 1. But now I want outer and inner to add up to 15x instead of 9x. So that means I'll place 7 here and 1 here because that would give me 14 and 1. See, I don't need to write it out. I can just kind of look. 14 and 1 would give me 15x in the middle. So flip this page over. I'm not doing all of these with you, but let me choose a couple that are a little more challenging. So we don't always have prime numbers. So let me jump to, just going to choose a few. Let me jump to I here. Okay, so on I, here I have this trinomial 10x squared plus 13x minus 3. So first of all, this is the first time we're encountering a trinomial that there's more than one option. 10x squared, I could either break into 10x and x, or it could be 5 and 2, right? 10 has more than one set of factors. It's not a, oops, I didn't write a 2. It's not a prime number, okay? I'm going to start looking at 5 and 2, and this is why, first of all, I use a pencil. And secondly, why it's called guess and check. I don't know if 5 and 2 is the right combination. I tend to start with one that's a little more evenly split. So instead of 10 and 1, 5 and 2, a little closer together, those two numbers. See if I can get a combo that works. If it doesn't work, then I erase it and I plug in 10x and 1x and restart the whole process. Now this time, I have a negative C value. So what this means is that I have opposite signs, or I have one positive or one negative. There's no way for me to know if it's positive here, negative here, or vice versa. So I have to look at the OI to decide how could I get a combo. One nice thing here is my last term's prime. So I know it's 3 and 1. How can I get a combo that will add to 13x in the middle? So I'm going to look at the OI. Is there a way that I can place 3 and 1 here to create 13? So let me just show you ways it could work out. I could go 3 and 1, which would give me 6x and 5x. I can't make this become 13. No way, no how. And I know that I have to have opposite signs. So making one positive, one negative, I'm not going to get there. If I put 1 here and 3 here, then I have 2x and 15x. And I can see that if I made this negative and this positive, which is important that I keep in mind that it has to be opposite signs, and I'll speak more to that in a minute. Okay, so good. With opposite signs, I can create 13 here. If I make this negative 2x and this positive 15x, that gives me the correct middle term. So here are my correct factors. Now, the reason I said that it's important that we keep in mind that a negative C value means opposite signs. Is I could see this happening to a student. That instead of 5 and 2, they start with 10 and 1, and that's fine. So they start there with those set of factors for their first term, and they're trying to place 3 and 1 and make 13. And they go, oh, well, if I go 3 and 1, I have 3x and 10x, right? Different factors. But in order for that to work, it would have to be positive, positive. Well, this trinomial does not have positive, positive. It has to have opposite signs. So these are not the correct factors, okay? It's an easy way to write incorrect factors. So whether you have the same sign and it's a little bit of a gift because you can just place them, or you have opposite signs, it's still important to keep the signs in mind when you're thinking about what set of factors work. So let's look at the one right underneath this K. So I have a prime leading term, which is nice, because I know it's just going to be 5x and x. I have a positive C value, which is nice because I can place my signs. This time I have a positive C value with a negative middle term. Positive C value means I have the same sign and it has to match the middle term. So I know it's negative, negative. And it has to be 2 negatives there. Now my last term is not prime. So 6 could be 6 and 1, or it could be 2 and 3. So I need to look at outer inner here and see, is there a way that I can create, or what way will allow me to create negative 13 in the middle? So take a moment and mentally place 6 and 1, 1 and 6, 2 and 3, 3 and 2. What's going to make this work? And what we want is 2 here, 3 here. These are the factors we want because it's going to give me negative 3, negative 10, giving me negative 13 for outer inner there, which is what we want. Here's my factored form. Okay, now let's do another one that's a little bit more challenging. Let's skip over to n. So I see n is more challenging for a couple of reasons. One is that neither my first or my last term is prime. So that just means I have a whole lot of more options. So 6x squared could either be 6x and x or 3x and 2x. I don't know. I'm just going to put 3x and 2x and see if I can find a combo that makes that work. If I can't, then I'll switch the leading factor. And 24 has all sorts of options, right? It could be 24 and 1, could be 12 and 2, it could be 4 and 6, it could be 8 and 3. See how this gets much more interesting depending on how the trinomial looks. Okay, so I have what's called a composite leading term, something that has more than one option, and then composite last term. So I'm going to start by trying 3 and 2 for my factors of 6. I have a negative C value, which also means I can't place my signs, but I have to keep in mind that I'm going to have opposite signs. And I want to find a combination that will work and make this OI, outer and inner, add up to 7y. So take a moment and look at our options, knowing that we're going to have opposite signs. How can I get to 7y using those factors? So I'm literally just running through in my head, okay, would 24 and 1 work? No. 1, 24, no. 12, 2, nope. What if it was 2, 12? Nope. I'm going through all of my factors. Then I get here and I go, okay, does 8, 3 work? 8 and 3 give me 16 and 9. And I know I have to have opposite signs, and that would work if I took 9 away from positive 16. So there's my opposite signs, right? And so I want positive here, negative here. And that's how I have to kind of figure out this puzzle. I have all of these options and I have to keep opposite signs. I know that as I'm going through. And I'm just kind of checking all of my options off. Here I am, there's my answer. Okay. I want to look at P and then I'll let you do the rest on your own. On P, again, I have a composite first term, so it could be 4x and 1x, or it could be 2x and 2x. I'm going to start with 2x and 2x. Positive C value, negative middle term, so negative, negative. And now I'm going to look, so 25 could either be 5 and 5, or 25 and 1. If I look here, 5 and 5, that's going to give me -10, -10. That's not going to work. And 25 and 1 wouldn't work either. So let me switch. See how flexible I have to be? Let me switch this. What if I made it, instead of 2 and 2, I do 4 and 1 for my first term? Now I have -20x, -5x, boom. There's my middle term. There's -25. Here are my correct factors. So you really you're puzzling it together, being really flexible with what you have. Just so you don't get confused when you start working, x squared, easiest one to factor. X squared is x and x. Okay, just 1x and 1x gives me 1x squared. And so on this one, maybe I'm looking at, I know I have opposite signs. Let's start with 8 and 11. Other options there, right? There could be 44 times 2, but I see 8 and 11 and a 3, and that looks pretty good to me. If I go 8 and 11, if I want it to be -3, then I want to see how it's just x here, so it makes it easier to think about your numbers. That's going to give me -3 in the middle. Here's my factored form. Okay, I've talked enough. So there's, I don't know, 9-ish of these left on this page that I want you to try on your own, and then play the video and I'll just show you the key. I'll just show you the correct factor. Okay, so now just check your work. Make sure you also check your signs as you go through. So here's a few that we haven't done quite yet that you can check. And you'll notice, like, when I have composite leading terms, I switch to pencil because I'm playing the same game where I'm trying to place these puzzle pieces in correctly. And L was also one we hadn't done together. And then moving down to these bottom 3. Again, making sure we check our signs as we look through.